Okay, we are here on R. Let me scroll back up to the top. I just got done making all this. So, Chapter 7 notes, March 24th. This is going to cover all Chapter 7. Again, 7.1, there's not going to be really any notes on R. It's very straightforward. But for 7.2 and 7.3, I got some really good notes on R. It's going to make things so much easier for us. And it's just a few terms, really. Not a big deal. I will post the knitted file as well as this video of explaining everything, so you can kind of follow along if you don't want to write everything, or if you want to make the file yourself and just pause as I go and you can hear the explanation. That's probably a really good idea. Keep in mind, I am doing this at home, so you may hear in the background my just beautiful children, so just a little added extra. So here we go. Let's go back to the PowerPoint where I said I would start this when we started seeing, there we go. Let's see, when we started seeing them use the chart. So let's see here. I'm going to bring this over a bit. All right. There we go. So here we have, it's a little smaller so it fits, maybe a little taller. Not going to do much. So here we have where we started, and we are given this question. Find the area under the standard normal curve to the left of z equals negative 0.38. Okay. Now they're going to just use the chart. They're going to give you this chart. We don't do that. That's a giant pain. So instead, we're going to use this formula right here. Let me see if I could do this. There we go. That way. Yeah, there we go. That way we can see both. So we're going to use this formula here. Okay. And it's just this at P norm. Basically, it's probability of a normal distribution. Easy enough. If all you have is z, and that's all they want, then yeah, this is what you're going to type in your z-score. And that's it. Now, lower tail equals true. This is important. This is area to the left. If this was area to the right, you're finding lower tail equals false. You're actually finding the upper tail, okay, not the lower tail. And that's really it for finding area to the left and to the right. I think I have an example on here as well. Now, you may notice that their answer is to 4 decimal places, so you're going to have to round. So we use our round function here. Okay. So again, area to the left is P norm. Type in the z-score they give you, comma, lower tail equals true. And again, this gives you the unrounded. You don't have to round if you don't want to. Just make sure that when you do answer it, you round correctly. All right. So here, just 1 second. All right, sorry, I had to take a pause there. It's kind of, I'm trying to reduce as much background noise as possible, but when you have a child playing with blocks, it kind of gets a little difficult. So, all right, so here again, you don't have to round. If you want to just go ahead and round, have it do the rounding for you, feel free. It's that easy. Okay, just round, and you can just copy and paste this, is all I did, and then put comma 4, whatever you want it to round to. All right. So the next question was area to the right. Now they have you do this, and we did it last year, area to the right, but R has since updated, and now you can just say area to the right is lower tail equals false. And that's it. So here, finding the area to the right of z equals 1.25, and it gives you, again, they're going to do it through that, there it is, 10.56, and when we round, 10.56. So the difference is area to the left, lower tail equals true, area to the right, lower tail equals false. And then we had area between. Now, area between is basically just 2 lower tails, area to the left, area to the left. Now, the big thing is you have to make sure you do this in order. You want to pick the biggest value first. So when they said find the area between negative 1.02 and 2.94, you're going to put the biggest value first. So p norm of the 2.94 lower tail equals true minus p norm of the smaller z-score, negative 1.02 lower tail equals true. And again, you can round this. And I'm going to do this to make it easier so we can see it all. All right, so we can see all the rounding. All right, I think that makes it a little bit easier to see. But yeah, there we go. There it is. P norm of the bigger z value minus p norm of the smaller z value, rounded to 4 decimal places. So and then that's all we do. That's how easy this is. Okay. So right here, again, this isn't going to be really helpful because you just are learning about z-scores. Again, z-scores are used to standardize any data set, so we're not given really any information on the data set. The 7.3 is going to be a little more useful because it's a little more practical. Hey, Ed. You want to say hey to everybody? I got the microphone. You say hey?
Hey.
She's so cute. Okay. Now, the question that came up next was find a z-score for a find a specific z-score. Okay. Now, I think I moved that somewhere. Okay. So we're going to type this in as we go. All right. So this uses, instead of p norm, since here we're trying to find the z-score, we're not trying to find the area, we're trying to find the z-score. They gave us the area. So we're going to use this. So this is finding the z-score for, not that for, the area to the left. All right. So, and that is going to use this formula. Insert R, Q norm. There it is, Q norm. We are going to use lower tail equals true, okay? But all this right here we don't need. We just need the area, which is 0.715, comma, lower tail equals true, because this is the area to the left, so true. All right, we're going to run that. So 57, and again, z-scores are rounded to 2 decimal places, so let's do our rounding. All right, so rounded to 2 decimal places. And again, I'm just going to copy this, paste it, and include the round parentheses down here, comma 2 close parentheses. So 0.57. And that's it. Okay, area to the right. Now, area to the right, I'm going to copy all this. That's because I like to copy and paste. Copy. Yeah, I must have skipped over these, I guess. Area to the right. All right, so here they gave us area to the right 0.30221. And I'm going to assume, I'm going to try this out, lower tail equals false because this is area to the right. And you do have to spell that correctly. False. We're going to see what the answer is. We should get 0.52. Yep, and then when we round this, I'm going to copy that. So Control C, Control V. I hear Elsa in the background right now. Where's it at? There it is. Okay, 0.52. I'm playing with Elsa. All right. Okay, finding the z-score that separates the middle 80%. Okay, so this one's going to be a bit interesting. To do that, we are going to kind of split the difference. The middle 80% leaves 20% on the tails. So we're going to find two different ones. So let me do this. Finding the area between, what was it? Finding the z-scores that separate the middle 80%. All right, so we're going to do two of these, and I'm going to just copy and paste really all this right here. So all right, so that. So again, since it's 80%, that means 20% for the tails. Okay, split evenly. So we need the left and right 10%. Okay, so I'm just going to put 0.1 here. In fact, I'm just going to get rid of this. I'm just going to do the rounded version of that. Okay, so I'm going to do 0.1. Get rid of that. And 0.1, just again, left and right. Oh, didn't want that. Okay, so here we're going to have the left z-score. Okay. Okay, and then here we're going to have the right z-score. Now again, here's the nice thing. They should be the same answer. Okay, just one positive, one negative. So negative 1.28, positive 1.28. So really, you only have to do the left or the right. Just, you know, if it splits the difference, it's going to be the same value because they're the same distance away from the center. So they're going to be the same value, just one's negative, one's positive. The center, the z-score, the center of every z-score is always 0. So that's why it's going to be the same value. All right, am I on track now? All right, the z alpha, okay, z subscript alpha, so z sub alpha is what it's called. That subscript is the area to the right, okay? So I have it all kind of all explained right here. The 0.25 represents area to the right, and this is asking for what z-score gives us an area to the right that is 0.25. That should be a lowercase. I get a little excited when I type, I guess. You know, I love the caps. All right, this is the opposite of what we have been doing. So again, Q norm is not really the opposite of what we've been doing, which is the same thing as what we've been doing. It's just area to the right. So exactly what we just did here, area to the right. It's just given in a different way. That subscript is always going to be area to the right. So if I ask you to find z subscript or z sub 0.75 or 0.95 or 0.05, that's always area to the right. So just include lower tails faults on these. I think that's it for 7.2. So we're going to move on to 7.3. Okay, now these are just practice questions. Feel free to do these on your own to see how you do. These are just some practice questions with the answer key there. All right, now 7.3 takes this a step further. And instead of giving us z-scores, they actually give us word problems. To where we would have to find the z-score first and then look it up in the chart. But instead of doing all that mess, we're just going to do it the easy way. So first question they give us here is, it is known the length of certain steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.45. Now, I put mu and sigma because mu represents population standard or population mean. It also means expected value. All right, just 1 second again. I got some more blocks playing in the background. So. All right, now they're gone. So, mu also could mean expected value. That's supposed to be 100 centimeters. They are designed and made to be 100 centimeters. Now, they have some standard deviation of 0.45. Okay, so what's the probability a randomly selected steel rod is a length of less than 0.922 or 99.2? So here, mu is 100, sigma is 0.5, and probability of less than 99.2. So this is how you write it, probability of x being less than 99.2. The only difference is, instead of just typing in the z-score, we type in this. We type in our x value. So I'm going to kind of put this in quotations so you know it should be p norm. I'm just going to copy this. So copy v. This is p norm, the x value. Mean equals mu. The standard deviation. Right now, we're going to talk more about standard deviation, okay, because we don't have a sample size. So we don't have a sample size. So what I'm going to do is do this, which is, oh no, we just basically sigma is your standard deviation. We don't have to worry about anything else. In chapter 8 or 9, one of those two, we're going to have something different, where we're not given the population standard deviation. We're given, or at least, sorry, this is actually wrong. In chapter 9 or 8, since we're just finding the probability of one selected steel rod instead of a bunch of them, our standard deviation is going to be exactly what they give us. If we have more than one, a sample size of more than one, we would have to include that. Okay, we'd have to actually find what's called the standard error, and that would be our standard deviation. Just 1 second. All right, sorry. Again, doing this at home. I tried. I can't keep staying up middle of the night doing this like I did with your other classes. So yeah, we have to deal with children here. All right. So again, like I was saying, if we have a sample size greater than 1, which here we don't, all of chapter 7, everything sample size is 1. All right, so since we have to worry about that, standard deviation is just what they tell us. Lower tail equals true. Basically, lower tail is always going to equal true if this is less than. If it's greater than, guess what? Lower tail equals false. So if you run this, okay, I don't know why I forget. I'll have to figure out how to not type that out. So I'll just put it up here instead. Okay, that way I won't type that out. So again, we always want to round our probability to 4 decimal places. So here's the same function, just rounded to 4 decimal places. Okay, now again, when you run this, you may see that my answer is off by 0.0002. The reason for that is because they found z-score and they rounded their z-score. I do not know a way to, unless we just go ahead and find z-score first, which I don't really care to do that. I just rather type it in. So just know that your answer may be a tiny bit off by usually just a couple of, that's 10 thousandths of a decimal place. All right, and that's fine. Okay, it's fine. It just means that we didn't round when we found z, where they rounded when they found z. That's the difference. All right. So next question here. The next question is find the probability between. So let's say again, if you're producing steel rods, you do want to have a specific measurement. Okay, you need to be around 100 centimeters, and let's say that anything that is outside that value. Anything that's outside that value is unacceptable. Okay, if it's too short, it's got to be, thrown away, or it's sent back to the wherever so they can melt it down. Okay, recycled. We'll say hopefully they recycle it. If it is too long, then it needs to be recut. Okay, so we want to find the probability that it's between the 99.8 and 100.3, because apparently that's acceptable. All right, so here, next question is between. So between, finding probability between, here's the setup. Same, pretty much the same, okay? Between, just like before, we would do the larger one minus the smaller one. Okay, so P norm, the larger value minus the smaller value. So, and again, we want to round this. So I wrote it a little bit easier, I think, to see. So rounding, and then parentheses, I just press enter to get the next line, minus, and then enter, and then the comma 4 at the end. So 0.4191. So that's the probability of, again, we're off by about 5 10,000ths of a decimal place. Okay, and again, that's expected because here we have two values we're not rounding for, where here they did round both values. So moving on, probability of less than or greater than. Okay, so here we have the combined verbal and quantitative scoring on GRE is normally distributed with a 1049, a standard deviation of 189. They want to know, oh no, I didn't do this question because it was pretty easy. So here we go at this steel rod question. They want to know what's the probability they must discard all rods if it's less than 99.1 or longer than 10.9. So this is back to that discarding question. They want to know what's the proportion. Again, probability, proportion, percent, area, they're all the same thing. That's all. Every single one of these could be any one of those. It just depends on what they want to know. Again, probability, proportion, percent, and area are the same thing. So here we have 100 steel rods, sigma equals 0.45 still, and here probably of less than or greater than, or just means we add. That's it. We just find both. So it doesn't matter what order you put this in. I think I wrote that wrong. It should be 91, not 92. Okay. So again, we just do the P norm of 99.1, mean, standard deviation, lower tail is true. Now, since it says greater than, P norm of 100.9, mean 100, standard deviation of 0.45, but lower tail equals false for greater than. Basically, every time it's greater than, lower tail equals false. And again, we just add. And again, we want this rounded to 4 decimal places, so 0.456. And again, we're off by 1/10,000th of a decimal place. Okay, so again, it's okay to be off by a little bit because they're rounding, we're not. All right. So now, last part, finding the value of the normal random variable. Okay, so here we are going to be, back to that GRE question. So they want to know what score do you have to make to be in the 85th percentile. Now, if they give you percentile, that is area to the left. So combine, here's the whole question. They give you 85th percentile. 85th percentile is area to the left. So this goes back to Q norm, and just like we did with P norm, instead of typing in the area, instead of typing in the z-score, okay, we typed in area first. Okay, so that is the area, the 85% is the area. Mean, standard deviation, lower tail equals true. And again, if it's area to the left, lower tail is true. And I gave a little warning here, this is not on your PowerPoint anywhere, but just in case if they ever give you top percent, there's something else we have to do. So you would have to make a 1246 to be in the 85 percentile, to basically score better than 85% of the people who took the test. So again, we're a little off by rounding by 1 whole decimal place because again, we don't round where they do. So that's the issue that we have here. All right, and again, it's okay. You'll be fine. So here where they rounded that z-score, and here we didn't round the z-score, so we're off by 1. Okay, and again, that's fine. Don't worry about it. I'm going to put all this on R anyway, so you should all end up with the same answers. Okay, so now what if they gave you the top 15%? What if they said, what score do you have to be in the top 15%? Now, top 15% is area to the right. So again, if that's area to the right, all you do is put false. So you put 0.15, same mean, same standard deviation, So by the way, if you're in the top 15%, that means you're above the bottom 85%. So it's the same answer. So 12, yeah, the exact same answer. The difference is we typed in the top percent, and we said area equals false, or lower tail equals false. Again, when you round here, because we're going to round nearest whole number, we round to 0. That says I don't want any decimals. That covers everything for Chapter 7. So I'm going to post this as soon as I go deal with some children. Alright, sorry, apparently a chair fell down on one of the kids, so you okay, Hadley? Yeah. You gonna say you're okay? Okay. So I'm gonna post this, and I will post the homework in a moment. Alright.